Alright, what we have on the screen right now is a 2 megacycle signal, and we are at the 50 nanosecond position, so 50 nanoseconds per division. So like I said, we would get one cycle displayed on the screen in 10 divisions, and that's exactly what we have here. We're starting, there's one complete cycle in 10 divisions, and we're running 20 volts peak to peak. We're in the 5 volt per division range. Now I'm going to change my range to 2 volts per division. We can go up 4 and down 4, so that's up 8. We can go 8 volts. Right now I'm going up 10. I can't handle that, so what I'm going to do is I'm going to drop my voltage down to 5. We're displaying 8 volts peak to peak. Here I'm going up 5, up 3 more, be 8 volts. And there's our 8 volts. So we are linear at our fastest speed, and our time base is accurate at our fastest speed, and we're going to reduce our voltage again so that we can get down to the next level. Check our calibration. Okay. We are up 4 volts, down 4 volts. That's 8 volts peak to peak. We are on the 1 volt per division level. If I was to go to the 2 volt per division level, we'd go up 2 and down 2. So we're in calibration vertically, and we are still displaying the 1 cycle at the 50 nanosecond per division rate. Alright, let's drop our voltage once more. Right. Up 4, down 4 divisions at a half volt per division. That would be up 2 volts, down 2 volts, 4 volts peak to peak, and again we are showing the 2 megahertz trace, 1 cycle in 10 divisions, so 50 nanoseconds. Alright, we're at 0.2 volts per division. 0.2 volts per division, we've got full scale deflection. That's 0.8 volts up, 0.8 volts down. We're running at 2 megahertz, and we are displaying a linear signal. We are now running 0.1 volts per vertical division. Alright, so we have 0.4 up, 0.4 down. The 1 cycle 20 megahertz display. And let's go to, let's cut this in half. Go to the next lowest position, 50. And touch up our 0. Okay, we are accurately displaying our vertical. Cut this down to handle the 20 millivolts per division, and at 50 millivolts per division we are running 50 plus approximately half, so that would be 70, and here I'm 80, so must have been 80 here. I just can't, yeah. Alright, so it's 3/10 of the way up. And if I cut this in half, I should be able to go to the next step. and be at full scale. Zero it. That would be full scale right there. So let's go back. Okay. Full scale. And we're getting to the ranges now where we're at our most sensitive, so we're... Alright, we're running at 2 megacycles. We are at a 5 millivolt per division, vertical. And we're up 4, down 4, so that's 8 divisions total, times 5 would be 40 millivolts peak to peak. And we are displaying 1 cycle of our triangle wave in 10 divisions, which is what we should because we are running at 50 nanoseconds. We are linear at our lowest millivolt scale and at our fastest speed. I wanted to demonstrate that during the calibration steps I was going through, I noticed that both channel 1 and channel 2 were noisy at the lowest steps, and I went ahead and opened it up and I carefully cleaned the switches, and you'll notice now that on the lowest steps there's no jitteriness, nothing displayed at all. That's on channel 2. Let's go ahead and switch to channel 1. And okay. Here's channel 1. And we're on the lowest step right now, and again, no jitteriness at all. It's nice and solid. So the switches have been cleaned, and that's one less thing that anybody has to worry about in the other end. One of the other functions of the scope is that we have a times 10 magnifying position, and if I pull, then we display our signal time base wise times 10. So here we are running approximately 1 cycle per division, so we're running, and that's at 1 millisecond, so we're running about 1,000 hertz here. That's a 1 kilohertz signal, and if I pull this out times 10, I am seeing 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. I'm seeing a cycle in 10 divisions, so again, that's kilohertz. So our magnification is working. That's the point. Just pull the knob right there. There's your magnification. So once again, we are functioning just fine. Whoever gets this is getting a fine bench scope. This is a beautiful machine. 60 megahertz, very brilliant trace, and got a lot of life left in her. Happy bidding, boys. Thanks for listening.